Problem 6. Prove that for 3 less than or equals to r less than or equals to n minus 3 cr plus 3 into n minus 3 cr minus 1 plus 3 into n minus 3 cr minus 2 plus n minus 3 cr minus 3 equals to ncr. Okay, we know the formula ncr plus ncr minus 1. What is the formula ncr plus ncr minus 1? N plus 1 cr. Remember this formula. Okay, now see LHS part. LHS n minus 3 cr plus 3 into n minus 3 cr minus 1 plus 3 into n minus 3 cr minus 2 plus n minus 3 cr minus 3. Okay, see n minus 3 cr. So 3 into n minus 3 cr minus 1 split into two parts. So n minus 3 cr minus 1 plus 2 into n minus 3 cr minus 1. So n minus 3 cr minus 1, 2 into n minus 3 cr minus 1. So 1 plus 2, 3. Okay. Plus this one, third term. So can be divided into 2 into n minus 3 cr minus 2 plus n minus 3 cr minus 2. 2 plus 1, 3. Still what is the balance? n minus 3 cr minus 3. Okay. Now keep brackets for these two terms, next to two terms, next to two terms. Okay. See this formula. See, consider this one as ncr plus ncr minus 1. See, ncr plus ncr minus 1. What is the formula? N plus 1 cr. So here n is n minus 3. So n plus 1 cr directly. Okay. In these terms, 2 is the common. N minus 3 cr minus 1 plus n minus 3 cr minus 2 plus c. ncr, see, ncr plus ncr minus 1. R minus 2 minus 1 is r minus 3. So same concept. N plus 1 cr. Here n is n minus 3. N plus 1. N plus 1 cr is r minus 2. Next. So n minus 3 plus 2 is minus 2. cr plus 2 into c. ncr. N, this is ncr plus ncr minus 1. So r minus 1 minus 1 is r minus 2. So ncr plus ncr minus 1. What is the formula? N plus 1 cr. N plus 1 c. Here r is r minus 1 plus n minus 3 plus 1 is minus 2. C r minus 2. Okay. That equals to n minus 2 cr plus 2 into n minus 3 plus 1 n minus 2 cr minus 1 plus n minus 2 cr minus 2. That equals to n minus 2 cr plus c. 2 into n minus 2 cr minus 1 converted into n minus 2 cr minus 1 plus n minus 2 cr minus 1. So n minus 2 cr minus 1, n minus 2 cr minus 1 equals to 2 into n minus 2 cr minus 1 plus n minus 2 cr minus 2. Now keep brackets from the first two terms and the next two terms. See. Now see n cr plus n cr minus 1. Same formula. N plus 1 cr. N plus 1 cr plus here also ncr plus ncr minus 1. Okay, r minus 1 minus 1, r minus 2. So n minus 2 plus 1 C R minus 1. So n minus 2 plus 1 is minus 1. Minus 2 plus 1 is minus 1 CR plus here also n minus 2 plus 1. So n minus 1 CR minus 1. See NCR plus NCR minus 1. So n plus 1 CR. N plus 1 CR. So minus 1 plus 1 cancel. So n CR which equals to RHS. Problem number 7. Prove that 34C5 plus sigma R equals to 0 to 4, 38 minus R C4 equals to 39 C5. Okay. See the LHS part. 34 C5 plus sigma R equals to 0 to 4, 38 minus R C4. Sigma is nothing but addition. Okay. We know the formula. What is the formula? We know the formula is there. NCR plus NCR minus 1 equals to n plus 1 CR. Okay. 34 C5 plus sigma R equals to 0 to 4, 38 minus R C4. Here 0 is called lower limit, 4 is called upper limit. So sigma, first keep R equals to 0. 38 minus 0 C4. 38 minus 1 C4. 38 minus 2 C4. 38 minus 3 C4 plus 38 minus 4 C4. Okay, from right last to first. So for our convenience only, 38 minus 4, first R equals to 4, C4 plus 38 minus 3, C4 plus sigma is nothing but addition. 38 minus 2, C3 plus 38 minus 1, C4 plus 38 minus 0, C4. Okay, next step. So 34 C5 plus 38 minus 4, 34 C4. 38 minus 3, 35 C4. 38 minus 2, 36 C4. 37 C4. 38 C4. Okay. Now see carefully. NCR. See, this is NCR. NC 5 minus 1, 4. NCR plus NCR minus 1. What is the formula? NCR plus NCR minus 1. N plus 1 CR. So 34 plus 1. C R value 5. Remaining steps as this, terms as this. So 36 C4, 37 C4, 38 C4. 34 plus 1 is 35 C5. Okay, plus 35 C4 plus 36 C4 plus 37 C4 plus 38 C4. Now observe these two terms. NCR, NC 5 minus 1. 5 minus 1 is 4. NCR minus 1. So again, NCR plus NCR minus 1 equals to N plus 1 CR. So this is 35 plus 1 CR. 35 plus 1 CR. CR value 5. So next, plus 36 C4, 37 C4, 38 C4. Next, 35 plus 1 is 36. 35 plus 1 is 36. 36 C5 plus 36 C4 plus 37 C4 plus 38 C4. Next, observe these two terms. So NCR plus NCR minus 1. Same N plus 1 CR. So that equals to 36 plus 1. C R value 5. Plus 37 C4 plus 38 C4. See, 36 plus 1 is 37. 37 C5 plus 37 C4 plus 38 C4. Keep brackets from these two terms. Again, NCR minus 1. So 5 minus 1 is 4. So n plus 1 CR. N plus 1 CR. So 37 plus 1. 37 plus 1 CR. R is 5 plus 38 C4. Next. 37 plus 1 is 37 plus 1 is 38. 37 plus 1 is 38. 38 C5. 38 C5 plus 38 C4. That equals to NCR minus 1. So n plus 1 C R is 5. So 38 plus 1 is 39 C5, which equals to RHS. Prove that 4n C2n by 2n Cn equals to 1 into 3 into 5 into so on 4n minus 1 divided by 1 into 3 into 5 into so on 2n minus 1 whole square. First, let us take LHS. What is LHS? 4n C2n by 2n Cn. We know the formula NCR. What is the formula of NCR? N factorial by n minus r factorial into r factorial. So this is how the form NCR. So n factorial by n minus r factorial. So n is 4n, r is 2n. N minus r factorial into r factorial divided by NCR, n factorial by n minus r factorial 2n Cn, 2n minus n factorial into n factorial. That equals to 4n factorial by 4n minus 2n is 2n factorial. Here also one more 2n factorial is there, by 2n factorial by 2n minus n is n factorial into n factorial. See another formula, a by b by c by d. What is the formula a by b by c by d? A by b times of reciprocal of c by d is d by c. So this is also like that only, a by b c by d. So a by 4n factorial by 2n factorial into 2n factorial, 2n factorial whole square into, see, a by b by c by d, c by d reciprocal is d by c. What is d here? N factorial into n factorial. So n factorial whole square by 2n factorial. Okay. Now expansion of 4n factorial. The expansion of n factorial is n into n minus 1 into n minus 2 into so on. So 4n factorial is 4n into 4n minus 1, 4n minus 2, so on, 5 into 4 into 3 into 2 into 1 divided by denominator also 2n factorial. So 2n into 2n minus 1, 2n minus 2, so on, 5 into 4 into 3 into 2 into 1 square. Still numerator n factorial is there, denominator 2n factorial is there. So in the numerator n factorial whole square, denominator 2n factorial. Okay. Now separate even numbers and odd numbers. That means even terms and odd terms. So even term 4n is even term. Next even term is 4n minus 2. Next even term is 4n minus 4. So on 4 into 2. Odd terms 4n minus 1. Next 4n minus 3. so on 3 times of 1 by C. 2n, here also separate even terms and odd terms. 2n, next even term is 2n minus 2, so on 4 into 2 square. Odd terms, so 2n minus 1, next odd term is 2n minus 3, so on 3, 1. Here also square, so square into n factorial whole square by 2n factorial. Now see, in the numerator, everywhere n is 2 is the common term. So take 2 is the common, 1, 2, 3, so on. So take 2 is the common. So 2n. Here also 2 is the common. 2 common means 2n minus 1, so on. Take 2 is the common, 2, 1. How many 2's are there? 1, 2, 3, 4, 5 up to 2n's. So 2 power 2n. 2 power 2n. Okay. Into 4n minus 1, 4n minus 3, so on 3 into 1 by denominator also take 2 is the common. Take 2 is the common, n. Take 2 is the common here, n minus 1, so on 2, 1. So how many 2's are there? 1, 2, 3, 4, 5, so on up to n. So 2 power n. Square is there, right square. Into 2n minus 1, 2n minus 3, so on 3 into 1 square. Multiply with n factorial whole square by 2n factorial. Okay. See, 2 power 2n into 2n minus 1, so on 2 into 1 into 4n minus 1, right from last to first, 1 into 3 into 5, so on 4n minus 1 divided by a power m whole power n, 2 power n whole square is nothing but 2 power 2n. So write this term, n into n minus 1 into n minus 2 into so on. This term is n factorial. Square is there, write this square. Okay. Into 1, 3, 5, so on. So write 1 into 3 into 5 into so on 2n minus 1 whole square into n factorial whole square by 2n factorial. Okay. See, 1 into 2 into 3 into so on up to 2n. So this is the value 2n factorial. This is the value 2n factorial. Okay, now see 2 power 2n get cancelled. 2 power 2n get cancelled. So n factorial whole square cancel. 2n factorial cancel. Still what is the final term? So 1 into see the last term, 1 into, so 3 into 5 into so on 4n minus 1 by 1 into 3 into 5 into so on 2n minus 1 whole square, which equals to RHS. In a class, there are 30 students. If each of student plays a chess game with each of the other student, then find the total number of chess games by them. Okay. In this class, how many students are there? 30 students. So total number of students equals to 30. Okay. Each pair of student plays one game to each other. So each pair of student plays exactly one game to one game with each other. Here observe that two persons, for example, two students are there. Let us say A and B. If A is playing with B, is same as B is playing with A. So A is playing with B is same as B is playing with A. Here order is not important, but here only we are taking only combinations. Okay, we are taking two students from out of 30. So total number of games equals to 30 students. We are choosing only 2 students. So 30 C2. So we know that NCR formula n factorial by n minus r factorial into r factorial. So 30 factorial by n factorial by n minus r factorial into r factorial. So 30 factorial. So 30 factorial by 30 minus 2 is 28 factorial. Multiply with 2 factorial. 30 factorial can be written as 30 times of 29 times of 28 factorial by 28 factorial into 2 factorial. So 28 factorial get cancelled. 2 factorial can be written as 2 times of 1. 2 times of 1. So 2 how many times? 15 times. So for 15 times of 29. 15 times of 29. 15 times of 29 is 435 games. See the problem number 10. Find the number of ways of selecting 3 vowels and 2 consonants from the letters of the word equation. Selecting is nothing but combination. Remember the point. Selection is nothing but combination. Arrangement is nothing but permutation. The difference between permutation and combination is selections, combinations. Permutation means arrangements. Okay. So here what is the equation? What is the word equation? Given the word equation. Given the word equation, how many vowels are there? What are the vowels? A, E, I, O are called the vowels. E, U, A, I, O. Number of vowels equals to 5. E, U, A, I, O. So 5. Number of consonants other than vowels are called consonants. So 1, 2, 3. Okay. See, number of ways of selecting 3 vowels. How many vowels are there here? 5 vowels. Okay. Number of ways of selecting. Okay. 3 vowels out of 5 vowels. So 3 vowels out of 5 vowels. So 5 vowels are there. We are selecting only 3. 5 C3. Next. Number of ways of selecting. Next one is what? 2 consonants. 2 consonants out of how many consonants are there? 3. 3 equals to 3C2. 3C2. So now total number of ways of selecting 3 vowels and 2 consonants. Total number of ways of selecting 3 vowels and 2 consonants. 2 consonants from the letters of the word equation. is equals to, simply do the multiplication. 5c3 into 3c2. 5c3 into 3c2. We know the formula. What is the formula? LCM formula. N factorial by n minus r factorial into r factorial. Okay. So 5c3 means 5 factorial by 5 minus 3 factorial into 3 factorial. N factorial by n minus r factorial into r factorial. Multiply with, this is also NCR. N factorial by n minus r factorial into r factorial. So that equals to 5 factorial by 5 minus 3, how much? 2 factorial into 3 factorial equals to, multiply with 3 factorial by 3 minus 2, 1 factorial into 2 factorial. See now, 5 factorial can be written as 5 times of 4 times of 3 factorial divided by 2 factorial, nothing but 2 into 1, multiply with 3 factorial into 3 factorial can be written as 3 times of 2 factorial by 1 factorial value 1 into 2 factorial. Okay, now observe that 3 factorial get cancelled, 2 factorial get cancelled. 2 how many times? 2 times. So 5 times of 2 is, 5 times of 2 by 1 into 3 times 3 by 1. 5 times of 2 is 10, 10 times of 3 is 30. 30 by 1 is 30. So the number of ways is 30. Permutation and combinations, problem number 11. Find the number of diagonals of a polygon with 12 sides. Okay. The number of diagonals of a n-sided polygon is 1 by 2 into n minus 3. The number of diagonals of a n-sided polygon equals to half into n minus 3. Okay. Here how many sides are there? 12 sides. The number of diagonals of a 12-sided polygon equals to half into, 12, replace 12. 12 into 12 minus 3. Okay. See now, that equals to half into 12. 12 minus 3 is 9. So 2 how many times? 6 times. So 6 into 9. That equals to 54. So the number of diagonals are 54. Permutation combinations, exercise 6.3, problem 12. How many chords can be drawn through 21 points on a circle? This is a circle. The circle consists of 21 points. 21 points like this. Okay. So how many chords can be drawn? So chord means what? A line segment drawn. Any 2 points of the circle is called chord. So how many such chords can be drawn from 21 points on a circle? Okay. A chord have 2 points on a circle. Okay. So number of, here total how many points are there? 21 points. So total number of points on the circle equals to 21. So number of chords can be drawn through 21 points on a circle equals to, there 21 points are there. Okay, a chord can be drawn with 2 points, so 21 C2. 21 C2. What is the formula of NCR? Formula of NCR. So n factorial by n minus r factorial into r factorial. So 21 factorial by 21 minus 2 factorial into 2 factorial. So 21 factorial by 21 minus 2 is 19 factorial into 2 factorial. 21 factorial can be written as 21 times of 20 times of 19 factorial by 19 factorial into 2 factorial can be written as 2 times of 1. So 19 factorial get cancelled. So 21 into 20 by 2 into 1. 2 into 1. 2 how many times? 10 times. So 21 into 10 by 1. Okay, 21 into 10 by 9. 1 is 21 into 10 only. So 21 into 10, 210 chords. Therefore, the number of chords can be drawn. 21 points on a circle is 210 chords.